This is part 2 of section 10.4. Here's number 4. We need to find the surface area. What we're going to do is we're going to create an et out of this prism, and this is what you get. If you want me to clarify how we get this, just talk to me in class. But what I'm going to do is first I'm going to find the pH, or the lateral, and let me get a pen. Basically the lateral is going to be going around here, the left side, the right side, this sort of top and the bottom, and this is how you get this lateral. Notice that I have 17 times 2. The distance from here to here is 17, which is your perimeter, and the perimeter of this shape going around these sides, and the height, which is 2, and I get 34. Now I'm going to find the area of basically one of these, which is a trapezoid, and you know how to find the area of the trapezoid. Base 1 plus base 2 times the height, which is 4, divided by 2, and you end up with 18, and then you add 34 plus 2 bases, because this is just 1, I have 2, and I end up with the surface being 70 square centimeters. Let's move on to the next slide. It says find the surface area of the composite figure, round to the nearest tenth. So we're, again, just like number 4, we're going to create a net. And basically this is the net that you have, but I split the net. You should see the 2 rectangles with the following dimensions. Remember, this is coming from the circumference. And then these 2 donuts, or just one of the donuts, you know how to find let me get a pen here. You know how to find the area of the shaded, which is find the area of the big circle minus the area of the small circle. So let's go ahead and find the lateral, which is basically the outside surface area, which is here, and then the inside surface area, which is here. And again, the inside is coming from the inside of this 3-dimensional figure. There's a hole there, and that's what this surface area comes in. So let's go ahead and just compute these numbers. 2 pi 10 times the height, 2 pi 5 times the height, and you end up with 450 pi. And then at this point I'm going to compute the area of these 2 bases. So again, is the area of the big circle, which is 100, minus the area of the small circle, which is 25, and you multiply that by 2 because we have 2 bases. You add these 2 numbers, you get 600 pi, but I need to round to the nearest tenth, and once you do the rounding you get 1885 square inches. Let's move on to number 6. Here's number 6, is find the surface area of the composite figure, and we have to do some rounding as well. So let's find the lateral. Notice that in order for me to find the lateral, I need to find the lateral of the prism, which is going around here, the front, the back, the left, and the right, and also the lateral of the cylinder. So when I do that, this is what I get. I get 26 times 5. This is the perimeter of this prism times the height, and then the lateral of the cylinder is 2 pi, the radius times the height, and I end up with this 167.7. Then I'm going to find the surface area, which means that I need to find the area of the bases. And notice that the base in the bottom is the same thing as the base on the top. Picture the orthographic drawing from the top and bottom, and you're going to notice that you have a rectangle of 9 times rectangle with dimensions 9 and 4. So that's why you have 2 times 9 times 4 equals 72 for the 2 bases. So to finish this problem, the surface area is equal to what you see here. Let's move on to the next one. Here's number 7, same directions as the previous problems. So we're going to have to compute the surface area. Before we start playing with the laterals, I want you to understand that this distance there, which is the side of the square, is 3 radical 2. There's several ways that you can do this. Right now you should feel comfortable. If you want me to clarify this, just talk to me in class. So here we go. The lateral is basically computing the surface, the lateral of the prism and the lateral of the cylinder. The prism, we're going to find the perimeter times, which is 3 radical 2 times 4, times the height, which is 5. And for the cylinder is the radius times 2 pi times the height. That's why you see this is the surface area, the lateral for the prism, and this is for the cylinder. Then I punch this into the calculator, I round to the tens, and I get 179.1. From here, I am going to find the area of the basis. And to do that, I just need to compute the area of the circle and take away the area of the square. The circle with radius 3 is 9 pi. This square, I'm going to look at it as a rhombus, and I'm going to use the d1 times d2 divided by 2 formula. And you should know why by now. Then at this point, I basically simplify this, and I end up with 20.55. Then my surface area is the sum of these two numbers, and is 196.6 square centimeters. Let's move on to the next slide. This problem is a little bit different. It says you need to explore the effects on change in dimensions. Follow along. The edge length of the cube is tripled. Describe the effect on the surface area. So let's go and find the surface area of this prism or this cube, which is 384. I am going to actually do this a long way, and eventually you should be able to see the shortcut. So if I actually draw the new cube after tripling the dimensions, this is what you have. I compute the surface area, and this is what I get. Now, notice that 356 is equal to 9 times 384. Just do some division. Take this number here and divide it by this, and that's how you get this 9. Now, this is how you answer this portion of the problem. Describe the effect on the surface area. And this is how you answer. If the length, width, and height are tripled, the surface area is multiplied by 3 squared or 9. How can you come up with this answer, or basically this value, which is the same, without doing these steps? All you need to do is go here to this word. Notice that this word represents the number 3. How do you get 3? How do you get 9? All you need to do is you take this number and you're going to square it. That's what we have here. Why are you squaring it? Because we're working with area. And I can clarify this even more if you talk to me in class. Let's go to the next one. Here's number 9. It says the sides of the prism are multiplied by half. Describe the effect on the surface area. So let's do this the long way. This is the original dimensions. The surface area is 320. You should know how to do this. And again, I can clarify this in class. So if I was to multiply the dimensions by half, this is what I get. I get 3, 4, and 4. If I compute the dimensions, the surface area with these new dimensions, I get 80. Now, you should be able to see that to go from 320 to 80, I need to divide it by something. Okay? And notice basically he's dividing by 4. So now you can answer the question, but let me remind you something. Remember, multiplying by a fourth is the same thing as dividing by a 4. And this is how you answer the question. This is how you describe the effect on the surface area. If the length, width, and height are multiplied by a half, the surface area is multiplied by 1 over 2 squared or divided by 4. You could also see this as 1/4. Multiplied by 1/4 or divided by 4. Now again, how can we come up with this answer, multiplied by 4, divided by 4, without going through these steps and changing the dimensions? All you need to do is you take this and you're going to square it. And again, multiplying by a fourth is the same thing as dividing by 4. Let's move on to the last one. So you can read it. I'm just going to give you the answer. You can go ahead and answer this question now. Pause the video. Hopefully you did, but this is the answer. This concludes video 10.4 part 2.